This is part 2 of our lesson on probability, and we're looking at example 3 where we're talking about drawing cards from a well-shuffled deck of 52 playing cards. Now, in case you don't play cards a lot, let's just review that a deck of cards is made up of 2 colors. If I can find a pen. So there are 26 red, 26 black, for a total of 52. Of the red, there are 13 diamonds and 13 hearts. Of the black, there are 13 clubs and 13 spades. And then in each, and these are called suits, so in the diamonds, there is an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there are 3 face cards, a jack, a queen, and a king. And this is for each suit. So this is the sequence of cards of the diamonds and of the hearts and of the clubs and of the spades. There's the 13 cards. So what we're looking for is 4 cards drawn from a well-shuffled deck of 52 cards, so it's random. What is the probability that all 4 of them are red? So we're looking for the probability that all 4 are red. So that means we're looking for the ways to draw 4 red cards. And that will be divided by the total number of ways to draw 4 cards out of the deck. Now, order doesn't matter here. So we are looking for combinations. That's something we studied back in section 12.3. So this probability is going to be a combination, and we have how many red cards? We have 26 red cards, and we are choosing 4. And then we are dividing that by, we just reach in the deck, we pull out 4 cards. That would be the combination of 52 cards taken 4 at a time. Now when we put this in our calculator, if we just put the combinations in there, we're going to end up with 0.0552, and it goes on for our probability. Now in MATLAB you will be asked to do some rounding, and I think on this particular problem it wanted us to round to hundredths, so that will be approximately 0.06. But just the idea, the concept of using playing cards to calculate probability as practice problems, there are so many different ways that you can do this. Now remember, if your calculator isn't doing the combinations using the function that looks like C things, combination of n things taken r at a time, you can go back and use the formula, and that would be back in section 12.3. So let's look at another example. Here we have a table, and we have residents of a town are voting on building a racetrack in their towns. We have how many live in town. We have 3,035 that support, 430 that oppose. Outside the town, 3,972 support, 571 oppose. We want the probability that a person is selected to interview and that person supports building the racetrack. So we want the probability that we select randomly a person and they are a supporter. So On top we will have the number of supporters. That would be a success, that we choose a random person and they're a supporter, and that's over the number of all residents. Now in order to find these numbers, you'll have to do some calculations. We're going to add these two numbers. So the total number of supporters is 7,007. And because I need a total, I'm going to go ahead and calculate the total number that oppose, which is 1,001. And that makes my total here of 8,008 people, residents of this town. My probability then will be the number of supporters, which is 7,007, and that's divided by 8,008, and that's going to give you 0.875 when you put that into your calculator. Now, oftentimes when you're talking about probability, people will say odds, especially with horse racing. The odds are, or in ball games and things in sports. What are the odds in favor of a person supporting the racetrack? Well, this fraction right here represents the probability that we choose a random person and that person is a supporter. So odds are different because odds are the ratio between, so this is what odds are, those that are in favor compared to those that are against. So if it's a horse race, it's how many possibilities to win against how many possibilities to lose. So the odds for the person supporting the racetrack that we chose would be in favor 7,007 and opposed 1,001. And when we simplify this, we find that our odds are 7 to 1. So that's the odds, a different way of expressing something similar to probability, but a different definition of. And then our final example, we're looking at cookies in a basket, and this is just real good practice in calculating these probabilities. So on our first one, we want what is the probability that we select a peanut butter. So that will be the number of peanut butter, which is 16, divided by the total. When I add 16, 14, 18, and 32, that is 80. Calculation here, we could simplify this if we want a fraction, and that would be 1 over 5, or we can go ahead and calculate it as 0.2. So that's the probability that we reach into the basket, we pull a cookie, and it's a peanut butter cookie. In the second one, we want to pull a cookie and it not be a mint. So what's the probability that we reach in there without looking and just pick out a cookie? So that's the probability that it is not mint. Well, that's going to be the probability that it's everything else. So it could be a sugar, it could be a caramel, it could be a peanut butter, but not mint. And then that's all divided by my total here. Let me just mark these totals for you. So this total, when we add all of those numbers up, on this first one is 80. And my total on the second one, 15 plus 12 plus 3 plus 20, my total is 50. So that's what I'm dividing here. I could pull out 50 cookies. That's the total number. So I've got 27 plus 3, so I have 30 over 50, which would simplify to 3 over 5, or as decimal, that will be 0.6. The probability that we will reach in and draw out a cookie randomly and it not be a mint is a 0.6 chance. A little better than half to half, than even, that it's going to be a 50% chance. which, remember, these probabilities can be expressed as percents. In our last two examples, we want the probability, and now we're going to do two different types. So we want the probability that it is peanut butter or, and we'll be looking at this more carefully and in more detail when we get to class next Wednesday after break. So a peanut butter or a caramel. Well, there are 28 peanut butter and there are 21 caramel. So either way, if we pick either one of those, that is a success. That's the outcome we want. And my total here is 70. Let me go ahead and put this total in for you. So then that gives me 49 out of 70. Which is 7/10 or 0.7 probability. And in my last example, I want not a peanut butter, not a mint. So then success would only be if we pull a caramel or a sugar. And that's divided by 90. So I have 36 out of 90, which is going to give me 2/5, or 0.4 as a probability. So get on the homework. Get started with that as soon as you can. I know you're on break, but if you could finish that homework before we get back to class next Wednesday, that will help us to wrap up our section on probability. Please be thinking about projects. They are going to come up pretty soon, and remember that they are 25% of your grade. So I will be available via email. If you have questions, please send those to me. And have a great break.